Hello everyone. In the previous session we have seen various pre-trained language models like BERT and how it is pre-trained, how it is fine-tuned to perform specific tasks. So we have seen BERT. In today's session we'll be learning some more pre-trained language models like ELMO, XLNet, Roberta, etc. So ELMO stands for Embedded or Embeddings from Language Models. Embeddings from language models, which is a deep contextualized word representation model which was introduced in 2018. What it does is it captures the meanings of various words and how they are used in various contexts, like it differs from the traditional word embedding models like word to vector and GLOVE, and it is not limited to a single vector for each word regardless of the context. The two models which are listed out here are assigning the word to a single context vector irrespective of the various contexts a word can be used. What are the key features of ELMO? First one, contextualized word embeddings. This ELMO can generate different word embeddings for the same word depending on the context. Say for example, you are using the word bank. Bank can be used with respect to a financial institution. Bank can also be used with respect to a river bank. So it can identify in which context you are using the word bank. Similarly, deep layered representations, ELMO uses a deep bidirectional long short term memory, that is LSTM network model, and it will try to understand the language wherein the embeddings are derived from multiple layers, wherein each layer is trying to capture some of the language features, and one layer identifies some features, another layer identifies some features. So you are trying to make sure each layer is capturing different linguistic features. Say for example, the lower level layers will try to capture the syntax of the language, wherein the higher layers are trying to capture semantics of the language. Syntax, we know how a particular word is to be pronounced or how a particular word is to be spelled. Semantics, what exactly is the meaning of the word in that particular context. Pre-trained on a large corpus, ELMO, just like BERT, is pre-trained on a huge amounts of data, approximately 1 billion words, using language modeling task. Later it can be fine-tuned just like BERT in order to perform specific tasks. Bidirectional context, ELMO's LSTM model reads the input text in both the directions, both forward as well as backward, and it can gain a richer understanding of the context in which a specific word is appearing. What are the advantages? Because it is trying to have so many features like understanding the context, processing it bidirectionally, and it is trained on huge amounts of data set. Naturally the performance will be an advantage to this model. So there is improved performance in this model. Context sensitivity, ELMO can handle various types of contexts, and it can also handle polysemous words wherein single word can have multiple meanings. Just now we have seen the example bank. Bank can be used in connection to a financial institution, or it can be used in connection to a river bank. Similarly, SAW, saw. Saw can be used as a verb wherein you are meaning I have seen something. Similarly, the same SAW can be used as a noun, which is a wooden carving tool or a carpentry tool, right? So you are trying to talk about. Similarly, bat. Bat is a word which has various meanings. Bat can be something with which we play, like a cricket bat, shuttle bat, likewise, or bat can be the bird or mammal which can be seen during the night, right? So you are trying to gain the advantage from Elmo, which can handle polysemous words which have a single word with multiple meanings. When can this happen? When can it understand a single word with multiple meanings? When it understands the context. What are the applications? Elmo can be used in various NLP applications like translation, information retrieval, sentiment analysis, etc. So to summarize, it has enhanced word representations, and it can have it can generate actually context sensitive embeddings, and it is proven to be a powerful tool to work with NLP tasks. Another pre-trained model is XLNet, which is a transformer based language model which is introduced by Google at Carnegie Mellon University in 2019. It is an improvement on BERT, wherein BERT has some of the limitations, wherein it was still failing with some contextual understandings. So this XLNet is trying to improve those limitations, and it is trying to give a comparatively better performance. What are the key features of that? Permutation based training. Unlike BERT, wherein BERT was going for masked language model, which is predicting some of the masked words, XLNet uses permutation language modeling. What do you mean by that? It considers all possible permutations of a particular word during the training process, and also it can learn from both the directions, bidirectional, and there is no need for masking. So XLNet can predict the words based on both left to right and right to left dependencies, wherein it is giving a richer context understanding compared to BERT. Generalized autoregressive model. XLNet is an autoregressive model which can predict the words sequentially, and it can also generalize the prediction by combining autoregressive as well as auto encoding models which are used in BERT. So it can help the model to understand various dependencies in a better way. Transformer XL architecture. This XLNet is built on top of Transformer XL architecture, which makes it very suitable for understanding longer text sequences, and attention mechanisms are useful in understanding long range dependencies, and it can overcome the limitation of fixed length context vector windows which are seen in models like BERT. So because it is trying to address the limitations of BERT, definitely it is achieving a superior performance compared to BERT. What are the advantages? Because it is trying to address the limitations of BERT, we can say it is taking into consideration all possible contextual dependencies, and it is capturing the contextual information in a better manner, and it is able to handle longer sequences, and as I told, it is trying to overcome the limitations of BERT. It is outperforming the BERT. What are the applications? XLNet can be used in question answering, text classification, sentiment analysis, language modeling, which requires a huge amounts of context sensitivity. The other pre-trained model we are going to discuss today is RoBERTa, which is robustly optimized BERT pre-training approach. So this is also a critical improvement on BERT, which is pre-training approach, right? This is a transformer based model which is introduced by Facebook AI, that is Meta AI now, in 2019 as an improvement over BERT. What it is trying to do? It builds upon BERT by making various optimizations during the process of pre-training, which is trying to show its improvements in terms of performance while working for various natural language processing tasks. What are the key features of RoBERTa? It improves BERT's pre-training process by training on the huge amounts of data for a longer duration, and you are trying to have more data compared to BERT, and its training is done on significantly larger corpus, which includes common crawl news, web text and others, approximately 160 GB of text by the time this textbook has been written. Removal of next sentence prediction. BERT second objective is next sentence prediction. So BERT uses next sentence prediction as one of its pre-training objectives. RoBERTa removes this, wherein if I can easily identify what could be the next sentence, what could be the next word, I need not have sentence prediction as one of my training objectives. So this RoBERTa model allows the model to focus solely on masked language model, not on next sentence prediction. Dynamic masking. Unlike BERT's static masking, like same word is masked in all the training epochs. In BERT, we are masking approximately 15% of the words. In that, almost same word is masked, whereas here we go for different words in every trial. Larger batches and learning rate. It increases the batch size and learning rate compared to BERT, wherein you are trying to make the pre-training process more efficient and robust. What are the advantages? Because it is trying to address the limitations of BERT, naturally it gives better performance, and because it is trained on huge amounts of data compared to BERT, this is having improved pre-training, and this is pre-trained for a longer duration of time. And what is the other performance gain we are having from RoBERTa? No need for next sentence prediction. What are the applications? This can also be used in text classification, wherein you can even detect whether a particular text is a spam or not, topic classification, etc. It can be used in question answering applications. It can be used in named entity recognition, wherein you can identify the names of people, organizations, locations, etc. So the moment we include this in spell checker, say for example, no more the names of people, organization names and location names are highlighted as spelling flags. So this is an optimized version of BERT, which is having improvements during the pre-training, and it is trying to give huge impact on its performance. Thank you.